Welcome guys, this is VT engineering class and we are still under deflection of beam, and we'll be looking at what case 3 of cantilever beam, which is what a cantilever beam carrying a uniformly distributed load throughout the entire span of its length. So if you look at this diagram very well, you can see that at point A the beam is what is fixed. You understand? This thing is what it is fixed at this point. You understand? This point it is fixed, and at this point it is what it is at its free end. So if you look at this diagram, you can see that L is what the entire length of what of the beam. So now for us to determine deflection and maximum deflection at any section of this beam now, so what you are going to do is that for the first step is that we section any part. You understand? We section any part on this beam. You can decide to section this part. You can decide to section it. You can, as far as it's on this length of this beam, you can section this part. So assuming that I'm sectioning this part now, if I section this part now, let me call this place what? Section XX. You understand? So from here to here it's a distance. You understand? And from this point to this free end is also what? A distance. But don't forget that the total length of the beam is what? L. So now let me call this part now. Let me call it what? X distance. At this, I mean that from this fixed end A to this section X is what? X distance. So now where I section from this fixed end is what? X distance now. So for me to get the remaining distance here is what? L, the total length, minus X. You understand now? So which is what? This point is going to give me what? My L minus what? X. This is going to give me what? The total distance. The total distance of this one. So L minus X plus X will give me L, because negative X will cancel what? Positive X, which is going to give me my what? My entire length. So now, since we have already understand all this one now, so let's go into the calculation. So by sectioning this part now, but before we go into the calculation, so you know that when we have a uniformly distributed load, you understand, and we need to calculate, you understand, we need to calculate maybe the reaction at the support, or maybe we used to do some calculation, maybe shear force and bending moment. We need to convert this uniformly distributed load to what? To point load first. Assuming that you have something like this, a uniformly distributed load with what? Weight per unit length. Don't forget that your weight is given what? Per unit length. Therefore, for you to get the weight is what? To multiply. You understand? This was weight per unit length. You understand? For me to get the weight, I need to multiply it by length. So L will cancel L, which is what? Length. So to give me what? My what? My total weight. So now, when you have your total weight, it will be acting at the center. So I have something like this. Sorry. So now, when you have your total weight now, it will be acting at the center. Assuming that the total length is what? L. Let's say the total length of the beam is what? L. You understand? So when you convert it to point load, you understand now? So, and you have your total weight now. So it will be acting at what? L over 2. L over 2. So now, if you look at it what? In this case now, I'm considering this section now. You understand? When I'm considering this section now, I have a uniformly distributed load from this end to what? To this end. You understand? Let me call this point C. You understand? From point C to D, I have a uniformly distributed load, and the length is what? L minus X. So for me converting this one to point load now, I will have the weight acting at this center. You understand? And it will be acting between what? L minus X over 2 and what? L minus X over 2. So for me to get the moment at this section now, and I know that my weight is what? At the center now. So the distance of my weight now will be what? Multiplied by what? L over L minus X over what? Over 2. So what I'm trying to say is that if I have moment at X, moment at this section now, I've already converted this one to point load. You understand? So when you convert UDL to point load, your load will be acting what? At the center. And the total length is what? L minus X. So by acting at the center now, this side now we have what? L minus X over 2, and this side we have L minus X over 2. So, and my force is coming to this side. You understand? So, but don't forget, before you start that one, either you use clockwise moment or anti-clockwise moment, or you use coordinate. You can decide to give your upward force positive and your downward force negative. And you can decide to keep this one what? Negative, and this one was positive. It depends on what and what you still have what? The same answer. I hope you understand. So now, in this case now, I want to give my upward force negative and my downward force to be what? To to be positive. So now I have a force here that is coming downward. When I convert this one to what? To point O, which is what? I have what? W is what? Positive, because my force is coming what? Downward. I've already given it positive. And the distance covered when it was coming to this section is what? L minus x over 2. So I'm going to have what? You know the distance covered is going to be what? W L minus x, because when I'm combining to point to this what? Weight per unit length, you need to multiply by length, you understand? So W L minus x, then multiply by L minus x over what? Over 2 is acting at the center of what? Of this point now. So I'm going to have, in this case now, I'm going to have what? So now, in this case now, my moment at section x. So my moment at section x now, I have L minus x here and L minus x, which is what? Squared. So I'm going to have what? W L minus x squared all over what? All over 2. So this is moment at what? At this section what? X. But don't forget, recall. But recall that what? Moment has already been established that E I equal to d square y over d square. So since moment equal to this one and moment equal to this one, definitely E I d square y over d square is equal to what? This one. So we are going to have what now? E I d square y over dx squared equals to what? W L minus x squared over 2. So I can call this one my what? My equation 1. So by calling this one my what? My equation 1. So the next step was what? To determine the slope at any section of the beam, and maximum slope, where our maximum slope is going to be when a uniformly distributed load is placed on top this beam. So in this case now we are going to integrate this what? Equation 1 with respect to what? With respect to s. So integrating So by integrating equation 1 now with what? With respect to x. So this one now, we are going to integrate it. Then when we integrate, we are going to have what? E I dy dx equals to what? So now, we are having w here, you understand? But in this case, we are going to integrate as a whole, because L minus x is what is carrying the what? The square. So by integrating this one now, which was square is what? Is the power of what? L minus x. We are going to have what? L minus x. The power, you just add 1 to the power, then multiply it by what? By the denominator is what? Keep. When I add 1 to the power, then multiply it by what? This denominator is going to give me what? 6 plus what? C1. Let me call this one my what? My equation 2. Where my C1 now is what? First constant of what? Integration. So now my C1, first constant of integration obtained at fixed end. My first constant of integration is obtained at this point here, which is what? The fixed point of what? Of the cantilever beam. When my x, at this point, my x, section x is equal to 0, understand? And my y is also equal to what? My y is also equal to 0. So now, my x is equal to 0, my y equal to 0, my dy dx is equal to 0. So definitely, automatically, this one is what? Equals to 0, and my x equal to 0. So now, my x equal to 0 here, so definitely C1 is what? C1 is going to give me what? WL key over 6. I hope you understand. But if you don't understand, you can break it down. So what we have here is what? EI dy over dx equals to what? Here, W is multiplying the bracket bar. So I'm going to have what? If I open this bracket, I'm going to have WL key over what? Over 6 minus W x key over what? Over 6 plus what? Plus C1. Technically, this is what I have here. So in this case now, my x equal to 0 and my dy dx equal to 0. Automatically, this one is what? Equals to 0, because my dy dx is what? Equals to 0. So now my x equal to 0, my x equals 0. Technically, this one is what? Equals to 0. But I have WL cube over 6 left here plus what? Plus C1. Definitely, I'm going to have what? WL cube over 6 plus what? Plus C1. So for me to get my C1 now, either this one cross to the other side or C1 cross to the other side. So by carrying this one to this other side now, you understand? So it's going to be what? C1 equals what? Negative WL cube over what? Over 6. So I'm going to have what now? So now this is the value of my what? C1. So what I'm going to do next is what? Substitute the value of this C1 now into my equation 2, where I have C1 here. I'm going to represent it with this value now to have my equation for slope. So now, setting the value of my C1 in equation 2 now, I'm going to have what? E, therefore, EI, this was my what? C1, which is what? Negative. So negative will neutralize this plus. So I'm going to have what? I'm going to have negative A, negative WL key over 6. So this equation now is the required equation for slope at any section of what? Of the beam. So let me write it for you. The equation for slope at any section of the beam. So but my maximum slope will occur as what? At B. I'm going to have my maximum slope at B, because don't forget that the same load is placed on this cantilever, and at this point it is fixed. You understand? Something is fixed at this point. Just imagine that it is fixed at what? At this point. So and the same load, you understand, is placed on this cantilever. So the maximum, you understand, the maximum slope will be what? At this edge of what? Of point B, because at A it is what? It is fixed. So for me, having my maximum slope is when the section L is equal to what? The entire length of the beam, which is what? When X is equal to L, I'm going to have what? My maximum slope. So therefore, maximum slope my maximum slope of course at what? At point B when X equals to L. So I know that this is the required equation for slope at any section of the beam. So for me to have my maximum slope now, I'm going to substitute anywhere I see X with what? L into this equation now. So by doing that, I'm going to have what? E, which is what? L minus L, which is going to give me what? The 0. The 0 cube will still give me 0. 0 multiplied by W over 6 will still give me what? 0 minus WL key over what? Over 6. I hope you understand how I got this value, because I represent X with what? L, and it gave me 0 multiplied by the whole, it still give me what? 0. So in this case now, so what I have left here is what? EI divided dx equals to what? Negative WL key over 6. But don't forget that I'm looking for my what? My maximum slope. So my maximum slope is what? Dy over dx. So for me to get my maximum slope, which is what? Dy over dx. So dy over dx. For me to get dy dx in this equation now is what? To divide both sides by what? EI over EI, which is what our lecturer we did it. So by dividing this side by EI, I'm going to have what? Dy over dx, which is what I'm looking for. So this point now, I'm going to have what? Minus WLK over 6EI. So now, this is the equation for what? Maximum slope at what? At any section of the beam. Equation for maximum. This equation is what? Equation for slope at what? At B. So now what next for us is to find what? Equation for deflection at any section of the beam and maximum deflection. So now to find equation for what? For deflection, we need to integrate what? The equation for slope, which is what? Which is what? This one. By integrating this one, we are going to have our equation for deflection. So now integrating this equation now with respect to x. So this is the equation I want to integrate. So I'm going to have what? EIY. Don't forget that I've already integrated. I'm still going to have my W. Don't forget that in this case is what? L minus S cube. You understand? L minus X. I'm still integrating with what? The whole. You understand? So if I integrate this one now, L minus S cube now, I'm going to have what? L minus X raised to power 4. Therefore we multiply by my what? My denominator. So I'm going to have what? L minus X raised to power 4. Don't forget that there is 6 down already. But this power is going to multiply what? My denominator, which is what? 4 times 6. So I'm going to have what? 24 here. I still have what? My L cube here, which is what? WL cube. But don't forget that in this case, we don't have any variable. You understand? Our variable is what? X. But here we don't have any variable. So that means that WL cube over 6 is what? A constant. So by integrating this one now, I'm just going to have a variable, which is what? X. So I'm going to have what? X over 6 plus C2. Let me call this one my equation what? Equation 3. So this equation now, C2 equals to what? When x equals to 0, y equals to 0, that's when I obtain my what? My C2. So in this case now, at fixed n, I obtain my what? At C2. So at this point now, my section x is what? 0 and my y is what? 0. So I know that my x equals 0, my y equals 0. So by inputting this into this equation now, I'm going to have my value for what? My value for C2. So now my y equals 0, automatically this one is what? 0. So my x equals 0, this one now will be what? 0. And this one now will be what? 0. Definitely my C2 is what? 0. So my C2. So it's a mistake. If you look at this very well, you can see that it was the value of my x, which was 0. So now for you to understand, let me open this bracket for you. So in this case now, I'm going to have my, don't forget that my y is what? 0. Automatically here, I'm going to have what? 0. Which is what? 0 multiplied by here is going to give me what? 0. So if I open this bracket now, I'm going to have what? WL 4 over 24 minus WX4 over 24. You understand? This is the bracket minus WLKX over what? Over 6 plus C2. You understand? And don't forget that my x is what? 0. So now in this case now, automatically this one like this is going to be what? 0. So if this one is equal to 0 now, you understand? This one also will be equal to 0. Then I'll be left with what? WL4 over what? Over 24. So in this case now, what I have left here, what I am left with this is what? WL4 over 24 plus C2. You understand? WL4 over 24 plus C2. So in this case now, my C2 is equal to what? WL4 over what? Over 24. So this is the value of my what? C2. You understand? Because these negative values are affecting what? C2. That's why I have my what? I have my what? Positive here. You understand? So this is the value of my C2. What I'm going to do next is what? Since I know the value of my C2, I'm going to substitute the value of my C2 into what? Into this equation now. So by substituting that, I'm going to have what? Substituting the value of C2 in equation 3, I'm going to have what? EIY equals to what? WL minus X4 over 24 minus WL4 over 24. So now this equation now, it is what? Equation for deflection at what? At any section of what? Of this beam. So this equation now, this is the equation for what? For deflection at any section of what? Of this beam. So, but don't forget that my maximum deflection is going to occur at what? At this point. You understand? Let me name this place B prime. B prime. My maximum deflection, Y max. So my maximum deflection is going to occur what? At this point now. So for me to have my maximum deflection at point B, that is when my section XX is what? Is the length of what? Of the beam from what? From where? From A. You understand now? So I'm going to have my maximum deflection when section XX is equal to what? The total length of what? Of the beam. So by considering this case now, my maximum deflection now is going to be what? Maximum deflection now will occur when what? At B, when what? X equals to L. So now by substituting X equal to L into this equation, I'm going to have my what? My equation for what? My maximum deflection. So in this case now, so I'm going to have what? Don't forget it is what? At B. So I can represent what with what? YB. So I'm going to have what? EI YB equals to what? In this case now, when what? When X equals to what? L. You understand? When X equals to L. So by representing L into this equation now, L minus L will be what? 0. Definitely all this one like this is going to cancel. So here now I have what? I have 0 minus. So in this case now, when X is what? When X equals to what? L. When X equals to L. So I have L cube here plus multiplied by another L is what? WL4 over what? Over 6 plus. So in this case now I don't have any what? I don't have any X. So I have what? WL4 over what? Over 24. You understand? So the next thing for me to do is that let me just write this one now. What I'm having here is this. Let me remove this zero. I'm going to have for negative WL4 over 6 plus WL4 over 24. So the next thing for me to do is that to find the LCM so that it will become what? One whole body. So by doing so, I know that the LCM of 24 and 6 is what? 24. So how many 6 can I see in 24? You understand? It's what? 4. 4 times this one is going to give me what? Minus 4 WL4. So I have positive here, which is what? Positive. 24 into 24 is what? 1. The 1 multiplied by WL4 is what? WL4. You understand? I have negative here, I have positive here. So now I'm going to have what EI YB is equals to what? So by removing this one from this one is what? Minus 3WL4 over 24. You understand now? So 3L1, 3 in 24 is what? Is what? 8. So now I'm going to have what? EIYB equals to what? Minus WL4 over what? Over 8. But the maximum deflection is what? YB. So for me to get my YB now is what? To divide both sides by what? By EI. So my YB now, by dividing both sides by EI, YB is going to be what? Minus WL4 over what? Over 8 EI. And this equation now is what? The equation for what? For maximum deflection. Y max at what? At this point, which is what? At what? At point B. Is what? The maximum deflection equation what? At point B, which is where we have what? We have our what? Our maximum deflection. So this is what? This is the last part of what? Of this calculation. So thank you for watching our video. Thank you very much. And please reverse us to your friend who might be in need of this. Thank you. This is VT Engineering Tutorial.